When we started to talk about vectors in the last section, we described vectors either using straight INJ notation for a vector, and then we also discussed describing a vector in terms of its magnitude, and then its magnitude with the cosine of the angle of the vector with, in that case, the x-axis, and the magnitude of the vector with the sine of the angle formed between the vector and the x-axis. So continuing along that line of thought, that we can use magnitude and sine or cosine to describe a vector, we're going to look at an alternative form for the dot product. So we already looked at how to calculate the dot product. Now we're going to consider another form of the dot product, where v dot w is going to be the magnitude of vector v multiplied by the magnitude of vector w. So we're going to multiply the magnitudes of both of these vectors, and then this is going to be multiplied by the cosine theta, where theta is going to be the angle in between these two vectors. And specifically, as it says here, theta is the smallest non-negative angle. So we're going to be going, defining this angle between the two vectors going in our counterclockwise direction. So this form, I mean, it's interesting, I suppose, but where we're going to use this more so is in this form, to find the angle between the two vectors. So if I look here at this formula again, and to isolate this cosine, if I were to divide both sides by the magnitude of these vectors here, these are gone. And on this side, I'm just left with the cosine of the angle in between the two vectors. And here we can see this fraction here. And that's what this is down here, just to show you where this comes from. So if what we're interested in isn't so much the dot product as the answer, but what we're looking to find is the cosine of the angle between these two vectors, we can use this formula. And here I just noticed I never went back and put in. So let's look at this first. This says that the cosine of the angle between, and again, the smallest non-negative angle between these, so we're going to be going in that counterclockwise direction, that the cosine of the angle between two vectors is the dot product of those two vectors over their magnitudes being multiplied. Now, if we want to go directly to finding our theta, we would take the inverse cos of this to give us our theta. So as I said, over here, I have this statement, and I didn't put in that this would be our theta. So if we find this information here and then input that into the inverse cos function, that will give us our angle that we're looking for. This example wants us to find the angle between these two vectors. So as you know by now, I like to make a picture sometimes to help us visualize what we are looking at here. So 1, 2, 3, 4. 1, 2, 3, and then here 1, 2. Okay, so vector v, we have 4, -3. So for vector v, 1, 2, 3, 4, and then -3. So we are there. And here is our vector v. For vector w, 1, 2. So 1, 2. There is our vector W, and I didn't put my little vector symbols here. So here are the two vectors that we're talking about. And this theta that we want is the angle in between these, again, positive angle. So we're going to be going in the counterclockwise direction. So here is our theta. That's the angle that we want to find here. So as you know, I like a picture can make more sense of what it is that we're looking to do here. Now we're going to calculate this. So just to rewrite the formula, we have that the cosine of this angle theta is V dot W over magnitude of V, magnitude of W. So I've just rewritten the formula down. And now we're going to need to find this information. All those bars certainly makes that kind of messy looking, doesn't it? So first thing, we need V dot W. So V dot W, we're going to be finding the dot product. So we're going to have 4 times 1 plus negative 3 times 2. So this is going to be equal to 4 minus 6, which is equal to negative 2. So there's the information that we're going to need for the numerator. So continuing here, V dot W, we have our negative 2 in the numerator. Now we need the magnitude of both. So magnitude of V, this is going to be 4, I was skipping to W. So we're going to have 4 squared plus negative 3 squared. So this is going to be 16 plus 9, which is our 25, which is 5. So the magnitude of V is 5. So I'm going to put my 5 in for the magnitude of vector V. Now we need to take a look at the magnitude of vector W. And I just realized I'm not putting those little vector symbols on top of these. This is looking kind of a lot of information as it is. I think it's just going to make a bigger mess. So I'm not using those symbols, but remember that they're there. So the magnitude of W, so now this is going to be our 1 squared plus 2 squared. So we have 1 plus 4. So we have the square root of 5. So the magnitude of vector W is square root 5. So putting this in the denominator. So here is the cosine of our theta. So cosine of theta is equal to this negative 2, 5 over square root 5. Now there's two ways that you can go about this. One is you could use this version of the formula and take the inverse cos of this information right now to get our angle. Or the other way you could do this would be to calculate this fraction here, which is about negative 0.1789. So if you do this on a calculator, you get this decimal number here, negative. So that says cosine is going to be in Q2. It's going to be bigger than 90 degrees, less than 180. And let's see what this angle is. So if we take the inverse cos of this, then we get that theta is about equal to 100.3 degrees. The problem asked us to do 1/10 of a degree, so I'm going to do 1/10 of a degree. So this angle, the theta itself, is 100.3 degrees. So when you get this isn't your answer. That's the actual cosine. You need to go then the additional step and find what the angle is.